EXIF tool gives you lots of options for exporting data. You can get it in a way that you can use with other software, or for use in a script. There are also export options that help in diagnosing files. The table option lets you export tags as a table, one column per tag, with tab characters separating the columns. Since file name is a tag, you can put it into the table to identify the file. Normally you want to specify just a few tag names, otherwise the table can get ridiculously wide. Here we're creating a table.txt file, so let's take a look at it. And you see it doesn't have any header, so you have to remember what each column name is, and it has dashes where there's no value for the tag. Another way is to use comma-separated values, or CSV. CSV is a popular format for importing to spreadsheets like Excel and OpenOffice. It's better than table in a couple of ways. It gives you a heading row that says what the column names are, and it automatically puts the source file name in the first column, so you don't have to include file name in the tags. Take out file name and create a file called output.csv. Then we run that, and now we can look at the file, output.csv. And you see that now it has, as the first row, a header that tells you the tags are source file, file type, and date time original, and the values of the tags separated by commas. EXIF tool changes some numeric values to a more readable form. In the common set, it does this with tags like focal length, shutter speed, etc. You might want to use the raw data if you're preparing output that other software will use. For this, use the printconv option. There are two minus signs in front of this option. Tags with a double minus generally indicate the opposite of the tag with a single minus. You could use printconv with one minus sign to tell EXIF tool to use human readable output, but usually that's not necessary. Maybe you need a specific date-time format in your output. You can get that. The default is year:month:day space hour:minute:second. Maybe you'd prefer month/day/year space hour:minute. You can do that. Make sure to include the quotation marks or you'll get a weird response. So there's output.csv, and let's look at that file. And now you see the date timestamps are in the new format. You'll notice that not all the files have a date time original field. The CSV output will still put commas in the right places, leaving blanks. But it doesn't affirmatively show that there's something there. If you prefer, you can use the force print option, which will put a hyphen wherever a tag is missing. So let's go now and put in force print, taking out the date-time formats, only because I don't want to confuse these examples by doing too many different things at once. So there's our file, and let's look at that one. And now you see the dashes at the end of each line, where there's a blank field. If you want the headers to show the group that each tag belongs to for clarity, then you can do that with the Group Headings option. So let's get rid of force print and put in Group Headings now. And then run this one. And take a look at the new output.csv. And you see in the first line you have EXIF date time original and file type. EXIF tool supports other output formats that could be useful for the software that's available to you. One of these is RDF XML. RDF stands for Rich Data Format. The option is XML format. If you have software that reads RDF XML, you might just be able to drop the EXIF tool output into your data files. So here's what it looks like. It's XML, uses the RDF namespace. But if you're up on computer programming trends, you know that JSON has been pushing XML aside in a lot of places. So you might find the JSON option useful. Let's get rid of XML format, change that to JSON. And let's make the file name output.json. Then we can run exiftool and take a look at the file we just created. Yes, output/output.json. And here it is, and it does look a bit more human readable, I think, than the XML does. Finally, here's an output option which can be very useful if you're familiar with the internals of a file and like doing visual analysis. The option HTML dump creates an HTML file which displays a hex dump of the source file and shows information next to it about where each tag is. This works only with the EXIF and JPEG metadata. So you see, if you hover over a tag name, then you highlight the tag and you highlight the data that goes with it. You can see exiftool offers lots of options for output. Don't forget to download the PDF in the resources for this lecture, since I don't really expect you've memorized all these options. What if? This lecture focuses on just one option in exiftool, the if option. This option lets you do conditional operations. It lets you change some tags based on the value of other tags in the same file, or even on those same tags. It's a powerful feature, and a complicated one. It's based on the syntax of the Perl programming language, which means we're getting close to the edge of real computer programming here. But I'll try to keep things reasonably simple, so that you don't actually have to be a Perl programmer to do useful things with it. Let's start with something relatively simple. Say we want to set the urgency value for all JPEG files to 3 if it's less than 3. In other words, no file should be more urgent than level 3. This is how we do it. The output says, 2 files failed condition, which might sound a little ominous, but it's what we wanted. It says 2 of the files didn't have an urgency less than 3, so they weren't touched. You should always put an if expression in quotes, so the command shell won't get confused by special characters. And there are some funny characters there. First, you put a $sign instead of a hyphen in front of the tag name urgency. Then, in order to work with urgency as a number, you have to put a $sign after the name to tell exiftool not to do a print conversion on it. You need to have the raw number to compare it. Then you give the condition, less than 3. If this condition is satisfied, exiftool will set the urgency to 3. If there's no urgency tag in a file, though, it'll fail the test, so it won't add an urgency tag. I'll tell you in a bit how to cover this situation. What follows if is called a logical expression. Logical expressions can get complicated. Use the verbose option to help figure out what's going wrong if you get error messages that don't make sense to you. If you're checking for equality, you use 2 equal signs in a row, not just 1. That's a common convention from computer programming languages. Here's an example. You say, faces detected =0. You can check for the presence or absence of a tag. Let's say you want to set urgency to 5 for all files that have the rights metadata element. You can check for it by just giving the tag name in the if expression. You can also test for the absence of a tag. This will set urgency to 6 if there isn't a rights tag. You can combine tests using the and or operators. which have to be lowercase. So now we can take care of the issue I mentioned before, and set urgency to 7 if urgency is less than 7, or if there isn't an urgency tag. If you're comparing strings of text characters, you use a different set of comparison operators. All I can say is there's no accounting for Perl. For string equality, you use EQ, and for inequality, you use NE, which stands for not equal. These are always lowercase. This is how you use an if option to set the rights tag to copyright me if the creator tag is my name. Since you're using single quotes for the whole if expression, you need to use double quotes to enclose the string value my name. String comparison is case sensitive. A string with uppercase letters isn't equal to a string with lowercase letters. You can use multiple if options in one command. In this case, they all have to be satisfied for the action to be taken. Here's an example. You can even use other operations like arithmetic. I really don't know just how far the expression language goes. For instance, instead of doing the low-res calculation the way we just did, we could do high-res calculation based on the sum of the image width and the image height. How complicated you can get with the if expression depends on how willing you are to experiment and how much you need to do. As usual, I'll mention that the details I've just discussed and a few other things are in the PDF resource for this lecture, so please read it. Let's look now at doing exiftool by the script, that is, with scripting features. I'm including in these three things. One is argument files. You can create argument files from exiftool, and you can use them to give arguments to every exiftool command from the same file. The second feature is being able to run multiple exiftool commands within one command line. And the third one is being able to run exiftool indefinitely, to keep feeding it commands as long as it runs. These features are useful if you've got some task that you need to do repetitively. If you've got a lot of files and you keep getting more every day, and you want to do the same operation, change the same tags on each file. Some of these things are best done under programmatic control. This could mean anything from having a one-off Perl or Python script of a few lines to having a web application that runs exiftool as a back-end. Let's look first at argument files. You can tell exiftool to pull its arguments from a file using the @ option. When you do this, there has to be one argument per line, not one option per line. You recognize arguments by the fact that they're separated by a space at the command level. An option might contain more than one argument. The spaces aren't hidden inside quotes or backslash escapes. That's how you recognize them. For example, with this command, there are three arguments: the definition of the title tag, the O option, and the file name that the O option uses. This is a title, and title tag are each part of one argument because the spaces are quoted, in one case by quotes, in the other by a backslash. So we can create an arguments file like this. You don't quote the values in an argument file. Also, be careful not to put trailing spaces in the file, or you might get odd warning messages. When I first set up this example, I didn't know about the trailing spaces issue, and I got a warning message which I didn't understand. I posted on the exiftool forum about this, and Phil Harvey himself gave me an answer in a few hours, clearing up the problem. The advantage of an arguments file is that you can put a complicated set of arguments, such as adding or removing a lot of tags, into a file, then use the same file on each of your target files. For instance, here's a file called personalize.args, which contains creator, keywords, and rights tags that you can copy into an image file. You can extract tags from a file and write them to an arguments file using the args option. We can extract the creator and rights tags that we just added. Kind of trivial, but here it is. We've created an arguments file and it has those tags. Another trick you can do in ExifTool is to give multiple commands in one line. You do this by interspersing the option execute in the command line. ExifTool picks up the arguments till it reaches an execute option. Then it executes a command with those arguments and starts fresh with the next argument after the execute. You can string together as many as you like. In this example, we extract the keywords from exterior.jpg and write them to keywords.mie. The execute tells it to do that before continuing. Then we tell it to use keywords.mie to copy its tags into streetart.jpg, and we see that it does that. Yes, you could do the same thing with two commands just as easily, so why bother? Well, one thing that can make it more useful is the common args option. This comes at the end of an ExifTool command. Any arguments that follow it are applied to every execute segment of the command. Here's another example where we give a different title to each JPEG, but use common args to give them all the same creator. Now, you can't put common args in an arguments file, but you can put an arguments file reference in common args. Really though, wouldn't you just copy and paste rather than make up this complicated command? Well, yes, if you're using the command line by hand, I'm sure you would. The real reason you might use execute is efficiency, if you're running batch operations. It takes a certain amount of computer time to start up ExifTool. If you're typing in commands, it doesn't matter, but if you're running a scripted process with a lot of files, it can make a difference in speed. If you're running ExifTool under the control of a script, there's one more trick you can do. The Stay Open option tells ExifTool not to quit when it reaches the end of an arguments file. Why is this useful? Because you can have another process that writes to the arguments file as data files become available. You can start up ExifTool, telling it to read an arguments file and stay open, and then have some other process that appends to the arguments file whenever it has a new file to process. Just make sure that the last argument of the group is execute, so it'll process everything. I'll illustrate it by using standard input, just because it's rather difficult to set up a demo using a real file. It works only if the source is actually appending to the file. Editing a file and saving additional lines doesn't work. So this isn't a practical example, but it shows the feature at work. We use the @ option followed by a minus to make standard input the arguments file. We ask for the version and then execute, and it gives the version and the confirmation ready. Then let's ask for the title tag of a file. And execute. And it gives us that. Finally, let's set Stay Open to false. And doing that makes it execute immediately. It doesn't even wait for an execute. This is definitely complicated stuff, but if you want to have some scripting control of ExifTool, it can be very helpful. Congratulations! If you've been paying close attention to all the lectures, and if you've been reading the resource files, then by now you have a pretty good understanding of how to use ExifTool. But there's still a lot more that hasn't been covered in this. EXIF tool just has huge amounts of options to cover. So, where do you go from here if you want to learn more? Well, the best place is the EXIF tool website itself. It has lots of documentation on installing EXIF tool, running it, using options, using the API, configuring it, and so on. That's where I got most of the information for this course, along with actually running EXIF tool and trying things. And one of the most important resources on that site is the EXIF tool forum, where you can ask questions and get answers. Or if you prefer, you can look through questions that have been asked before and see if somebody's asked the same question that you'd like answered. Maybe somebody has already got the answer there for you. There's an ebook, Practical EXIF Tool, by Dmitry Popov. It's very short. It's more of an e-booklet, really. But it's not expensive, and it has lots of examples. There are 4 YouTube videos by A.V. Preserve. They're rather introductory. They won't cover much that you haven't heard already, but still, sometimes it's useful to have another perspective on what you've heard already. It helps it to sink in. Another resource for asking questions is Stack Overflow. This is a website for asking questions about all kinds of tech topics, and it has a tag on EXIF tool. You can find the page with the questions with that tag. Sometimes that's a good place to get questions answered, though more often, really, I think you're better off to go to the EXIF tool forum. And finally, just try doing things. Experiment. Go wild. Just make sure you're working with copies of files so that you don't have to break anything permanently. For maybe the 100th time, I'll say, download all the resource documents and keep them available. The PDF for this lecture contains links to all the external resources that I've been talking about. Remember, you can keep asking me questions at any time about the material in this course. If you find that this course has been worth your money, then please tell your colleagues about it. And finally, thank you, thank you, thank you.
Конец. Конец.